what is the thought experiment behind E equals mc squared? Let's start with the experiment's setup. Let's say we are in space and we have these two lines just as visual guides help us see movement in space. Within the space, let's say we have a box where its left and right are labeled A and B. Inside the box on side A, we have a photon emitter, and inside the box on side B, we have a photon receiver. Now, the way this experiment works is that we have a box in empty space, meaning no forces are acting on it. As mentioned before, we have the box on side A, which is a photon emitter, and the box on side B, which detects the photons, or photon detector. Now, when still, the box is at position A and B, but when a photon is emitted towards the right, the box's position shifts towards the left to the new location of A and B, meaning the box shifts in the opposite direction of the photon's movement. But why does this happen? This is simply because of Newton's third law, stating that every action has an equal or opposite reaction. In the case of our box, the photon moving towards the right creates the opposite reaction of the box moving to the left. Additionally, the box is an empty space, meaning there's no external force acting on it. Because of this, and the fact that there is no external force, we can assume that the momentum of the photon is equal to the momentum of the box. This is the key point the rest of our work will be focusing on. In equation form, this is represented by m delta x over delta t equals E over c. M delta x over L delta t being the momentum of the box, which is the change in position over the change in time. And E over c being the momentum of a photon, which is energy divided by light speed. Now that we have our base equation, we are going to further it for accuracy. In the case of today's equation, we are going to take m delta x over t and find its center of mass equation form, which is basically the equation for the center of mass of the box. But why do we need to find the center of mass equation for the box? We need to find the center of mass equation for the box, or the CM equation for the box, because it's the only way to accurately measure a mass in empty space where there is no gravity. So what is center of mass? Let's say I have a mass in the form of a box. Well, the center of mass is a point in this mass where the weight is balanced so well that it's equal to 0. Calculating the center of mass for our box gives us mx1 plus mx2 over m1 plus m2, where mx1 is the mass of light times the box's distance, and mx2 is the mass of the box, which is distance moved in space. Then you have m1 and m2, which is the mass of light to mass of the box. When we expand this equation, we get mx1 minus mx1 plus m delta x equals negative mx2 plus mx2 plus mt. We can then simplify by cutting off like terms, leaving us with m delta x equals mt. Now we take our previous equation, equating the momentum of the box to the momentum of the photon, and we replace m delta x over t with mt over t, which, as mentioned before, is the more accurate center of mass version of the box's momentum. This leaves us with mt over t equals E over c squared. We can then simplify this above by canceling out the t's, giving us m equals E over c2. Since this is Einstein's thought experiment and he was trying to find energy, we rearranged the formula to solve for E, which finally gives us the famous E equals mc squared. And that concludes our topic for today. In front of you right now is a visual guide for those who like to have that on hand that I made. And just note that I am not a professional by any means in physics. So if you have anything to add, anything I got wrong, please comment below and I would love to learn from you and expand our knowledge together. I hope this video taught you something. Stay curious and keep questioning.